Hey, Algebra 1, Mr. Catlin here with your help for your first lesson on your homework this week. And we're starting a new unit on quadratic functions. And this first example that we've been looking at today is a situation where we have a certain amount of fence and we want to create different rectangles out of it and look at how the area is affected as we manipulate the length and the width of the rectangle. So, this particular yard, we have a rectangular shape, and it's given us a couple of examples that would work. It's saying, like, if I have a 30 meter by 20 meter, that would have 100 meters of fence all the way around because 20 plus 30 plus 20 plus 30 gives us that perimeter. So, the first thing that you notice is that the length and the width always add up to 50. They always have a sum of 50 because if you double that, you get the 100 of meters of fence that you need. So if 40 is the length, then that means that the width would have to be 10 to add up to 50, which when doubled gives you the 100 meters that you would use for the fence. So that's the first thing that we talked about in class today when we did the initial problem. I think ours had to add up to 25 because we had 50 meters of fencing, but this is a larger amount of fence. And obviously, to find out how much area is inside, you do length times width. So this particular one right here, where you have a 20 by 30, 2 times 3 is 6. You add 2 zeros. So this would have an area of 600. And this continues for all of them. 25 times 25 is 625. 35 times 15 is 525. And 40 times 10 is going to be 400. Now, the first thing it wants us to do is complete the table for the missing values. So that's pretty simple. We saw the relationships that are there. But what we started to notice today is that this relationship between length and area, when you plot it, it looks different. So, for example, if we were to plot this information here, let's actually do a little graph of it because it asks us to plot it. If we were to graph it, what would the graph look like? Well, the graph would have on the y-axis the area. So over here is going to be the area of the rectangle, and down here is going to be the length of your rectangle. And we can have lengths as they increase. We got 10, 20, 25. We go all the way from 0 to 40. So we'll have a 40 on here. We'll do 20 in the center, and then 10 would go here and 30 would go here. And our areas range anywhere from it looks like 4 to 700 or so. So let's do this. Let's put 800 at our top. We'll split that in half, make that 400. And then this would be 600. This would be 500. And we got our 700 right here. And really, those are the only ones that we need for our graph because everything I think is above 400. So we would have, when we graph this, we'd have 10 and 400, which would be there. We would have 20 and 600, which would be right about here. We'd have 25, which would be there, and 625, which is just a little bit more than the 600. And then we'd have 35 and 525, which would land us probably in this vicinity. And then 440 and 400, which would bring us back down kind of where we started. So as we notice in their example from class is that we're starting to see these functions that are creating these what we call parabolas or these hilltops that curve upward for a while and then they curve back downward. So the shape of the graph would look like a hill. The shape is a curve with both growth and loss. We see it's gaining and it's losing all in the same span here of 10 to 40 in length. How is this relationship between length and area of a rectangle different from other kinds of relationships we've seen before? We've never seen a curve that shows both growth and loss. And I guess I kind of answered number 3 there when I wrote down number 2, right? We've never seen a function of a curve with both increase and decrease. We've never seen that happen before. We've seen a curve that increased. We've seen a curve that's decreased. We've seen a straight line that's done both increase and decrease, like the absolute value and piecewise, but we've never seen a curve do both of those things at once. So that's how this one's new. And that's the beginning of our introduction into quadratic functions. Later, guys.